Using this model, we can easily determine the temperature on any day of the year. We just put the number of the day here, evaluate the function, and we get the average daily temperature for that day. Now, the average temperature on my birthday being October 14th, the 288th day of the year, we get by plugging in 288 for T. On a calculator, we would add 288 to 257.75, multiply that by 2 pi, which is about 6.28, that would be close enough, and divide that by 365. Then we'd have a quantity. We take the sign of that quantity, making sure that we're in radiant mode, multiply by 20, add 55. Now, when I did that, I got 58.2, and I don't think it's that high. I think I probably screwed up the calculator, but I was in the middle class and didn't want to go on with it. That might be right, but I kind of question it. My mental calculation doesn't want to confirm that. You should figure out the average daily temperature on your birthday. Good exercise. Here's another model, and it looks a whole lot like the previous one, except of course that the functions are slightly different. Okay, now I haven't actually drawn the model here, and I probably should have. But this is out of your text. You want the length of the day in Fairbanks versus the day of the year. Given that the shortest day of the year in Fairbanks has 3.7 hours of daylight. And when I say day length, I mean the length between sunrise and sunset. In order to model this, we have to determine where to put the circle. Now, the shortest day is 3.7 hours. That's going to correspond to day length maybe along this line. Where do we put the center of the circle? Well, the day length, as you should have read in your text, varies from a minimum to a maximum. It goes as far below 12 as it goes above 12, but the average for the year is going to be 12. And that's the line that we're going to use here. We're going to put the center of the circle at y equals 12. Now, if y equals 3.7 along this line and y equals 12 along this line, then pretty clearly the radius of the circle has to be 8.3. And if we go that much higher than 12, we're going to be at 20.3. So that the circle, or the day length, varies from y equals 3.7 to y equals 20.3. The circle is centered at y equals 12 with a radius of 8.3. That gives us two of our parameters, because remember the radius of the circle is our amplitude A, and the center of the circle is our vertical shift D. So we have A equals 8.3 and D equals 12. You can just barely see those down here in the corner. Omega, as in the preceding example, is 2 pi over 365. We just ask how long does it take to get around the whole circle and complete a cycle of the model, and we divide that number into our 2 pi radians of the circle. So now all we have to do is figure out how to shift this graph. Now, when does the minimum day length occur? Minimum day length occurs on December 21st. That's day 355. I've had the label of 365 over here with an arrow to the actual point because 355 is so close to 365. The low point of the standard sine graph with a 365-day cycle is at 273.75, and I haven't labeled that, but you remember that from the preceding example. So we have to shift the low point from where it would be 273.75 if we started at the standard starting point up to 355, which is December 21st. We have to shift this much. There we see it geometrically. We're shifting from 273.75 to 355, which means that we have a shift of 355 minus 273.75. That's a shift of 81.25, as we see down here. So now we have the 4 parameters we need to complete our model of the day length. So that our Fairbanks model, our model of day length in Fairbanks, Alaska, is as you see here. Here's our radius of the circle, the 8.3, the 2 pi over 365, giving us our angular velocity, the shift 81.25 horizontal shift, and the vertical shift of 12 to get the center of the circle up to y equals 12.